Hi, everyone. Welcome in to the Wind Energy Market Series. My name's Daniel. Today we are with Primus Wind Power, and we're just going to wait for everyone to kind of funnel in here. But before we dive in, yeah, we'll wait for a few more people to join in. Just so everyone does know, this is being recorded, and we will send you a link to the full recording after the webinar is complete. A quick few things about Renvu. I am a sales engineer here at Renvu. It was founded in 2013, based out of Mountain View, California, close to San Francisco. We do have fulfillment centers on the West and East Coast, as well as Texas. And if you are just joining in right now, we're just waiting for everyone. I'm going over a few things, so hang tight. No, nothing important, too important yet. At Renvu, our entire sales team has an engineering background, which allows us to go into depth on projects with our customers, whether it be a small residential DIY project up to those larger commercial projects. At Renvu, we don't just sell the product, we can assist you with any technical expertise that you require and be able to support you during your installation and commissioning, even post-commissioning. We do have a few perks for our customers, including the Megawatt Club membership, which gives you different deals based on engineering services and permit packages, as well as online tools to help you design your system, whether that be a solar system or even a wind-powered system as well. Once again, if you are just joining in, we are just waiting for more people to also join in, so we'll get started here in a few minutes. This is being recorded, and you will get a copy of that recording after this is complete. A few things to go over that are kind of paired well with different wind-powered systems and whole hybrid systems. First, we're looking at the Power Field ground mount ballasted solution. That's going to be in the top left of your screen right now. It's a pretty cool system where you can, it's these buckets essentially where you're putting gravel or earth into them, and that's your solar ground mount system. Moving over to the right, we have the Solarc 12K hybrid inverter. This is a excellent hybrid inverter that allows you to pair all sorts of energy storage systems and energy generation systems to combine into one hybrid system for whatever needs you need. Moving over one more to the Nlx Juice Box. This is a car charger for electric vehicles. You know, those are the new hot thing right now. But if you need one of those, that's something we also carry. And then we have our batteries on the bottom, which complete most wind and solar systems with energy storage. We have Fortress Power's eFlex 5.4 and their eVault 18.5 kWh batteries. And we also have Simplify's 3.8 48 volt batteries. And then Blue Planet Energy's Blue Ion batteries for the high end lithium ion battery compositions. Now, if you are just joining in, we are just going over a few products that Renvu has to offer. We're going to wait here probably another 1 to 2 minutes for people to jump in, and then we'll go ahead and get started. This is being recorded, and you will get a copy of that recording after this has been complete. All right, looks like we have quite a few people in here. I do want to make sure you guys know that we will be having a Q&A at the end of this webinar. We do ask that you put your questions in the Q&A and not in the chat. If you do need to use the chat, please use the chat if you are having technical difficulties and are unable to hear us or need our attention for something. We're going to try and only answer the questions from the Q&A, so please put all your questions in the Q&A. All right, well, looks like we're going to get started here. So today we do have Primus Wind Power with us. I'm going to introduce Ken here to you guys, and we can get the ball rolling here and see what Primus Wind Power has to offer.
All right. Daniel, you ready for me to introduce myself?
Yeah.
All right, great.
All you,
thanks.
Ken.
Thanks so much. And thanks to everybody who's been on this webinar today. I'm talking to you from beautiful Flagstaff, Arizona. It's a beautiful day, a little bit windy, which is what we like. Here's all my contact information right here, email, direct phone number, as well as customer service tech support phone number. And I do want to emphasize all of our products are proudly made in the USA. We build the turbine in Denver, Colorado, and service it. We have English speaking tech support, customer care, and so on. And we pride ourselves on a US quality made product that is serviced from the USA with a 5-year warranty, which is kind of unheard of in the small wind industry. Today we're going to be talking about wind, solar, and batteries and off-grid systems. So that's what we focus on. All of our turbines are off-grid battery charging turbines. So in about the next 45 minutes or so, we're going to just briefly go over the history of the AIR, specifications, the specs of the turbines, the 6 turbines we manufacture, the components, types, blade sets, applications, give you a little bit of a Wind 101 on towers, siting, and so on. Then operation, maintenance, installation of the turbine, how you determine a wind resource. That's critical, because if you don't have good wind, then it's better to go with more solar. Don't buy a wind turbine, go with more solar. And I'll give you the definition of what that means and how much wind you really should have. Why hybrid's a good idea, why off-grid's a good idea. And then I'll finish up with installation picks, a bunch of examples of different towers, different types of installations. And that's kind of the agenda for the next 40 minutes or so. So we started back in '95 right here in Flagstaff, Arizona with the AIR 303. You can tell this design hasn't changed over the last 25 years or so. This down tail design is kind of our signature nacelle design. Nacelle is the body of the turbine. Then we moved to the 403 in '98, and then in 2001, we changed the stator and the power electronic design entirely to what we have generally today. It's a 3-phase stator, electromagnetically brake stator, but still the outside of the turbine remained pretty much the same with a 1.5 Schedule 40 pipe that the yaw will accept. That's this part of the turbine right here, the yaw. And then we moved to the Breeze and the 40 in 2008 and the AIR Silent X in 2015. And then we just introduced just this month a new turbine called the AIR Max. I'll talk about that just this month. And so the reality of it is we've produced well over 175,000 units, the largest small scale wind turbine in the world. We have authorized service distributors all over the world, New Zealand, Australia, Europe, all over the world to help get you parts and pieces and blade sets and everything you need. And the turbine, the AIR turbine benefits from all these generations of improvements. It's not a new turbine, it's been around a long time. So specs of the turbine, really it's the average output right here is, depending on the unit, is 40 kilowatt hours a month or 30 kilowatt hours a month. It's a 1.07 meter rotor diameter turbine. The rotor diameter is, swept area. The rotor diameter is approximately 1.2 meters long. That's about 46 inches. That's from blade tip to blade tip on the entire diameter of the turbine. It's light. It weighs about 13 pounds. It ships really in a small package when we disassemble the hub and the rotor. And so it ships very inexpensively. Typically, it's about 20 bucks to ship. Startup or cut-in wind speed is for any turbine, and it's all dependent on elevation, right? But at sea level, it's about 7 or 8 miles per hour. We make them in all 3 voltages, 12, 24, and 48. The turbine is a smart controller, up-tower design, up-tower power electronics. That means the circuit card, the power electronics are in the nacelle. So what comes down tower is the DC output, 12, 24, 48 volt regulated DC. I'll talk a little bit more about that. It's cast aluminum. Depending on the blade set, it's carbon fiber or injection molded composite fiberglass and plastic. It has a permanent magnet brushless alternator, and the approximate survival speed is about 110 miles per hour of wind. And all of our turbines all mount with a 1.5-inch Schedule 40 pipe. That's the yaw mount. Sorry. So here's our latest blade set. This is a carbon fiber blade set that can actually go on any of our 6 models. It comes with a smart hub that actually the root, this is the root of the blade, fits inside this hub nice and tight. And then you put your 6 blade bolts in there. You don't have to do any tip-to-tip measurement on the blades, as some of you might remember from some of the older blade sets. And this is our latest carbon fiber blade. It goes with our Air Silent X and our Air Max turbines. This is what we call our blue blades. This is the older blade set. This blade set, it was now been in 2021 replaced by this blade set. Let's go through the turbine itself, an exploded view and how it works. So our turbine is called an upwind horizontal axis up tower controlled turbine. That's the design of the turbine. Upwind meaning the airflow of the wind direction comes in here, hits the nose cone and the blade set first, and then it goes across the nacelle, the body of the turbine hits the tail, and the tail helps it to stay on the wind. It is important though when you're putting a turbine up that you try to get your tower as plumb as possible, because that'll help with the energy output and production. But the tail helps keep the turbine on the wind. It's a 3-bladed turbine, which is the most, arguably the modern design for low wind and high wind environments. You got the bearings, this is the face, this is the stator that houses the copper windings. This is the rotor that inserts inside the stator, and then when you attach the blade set here to the end of the rotor. And then around the rotor, surrounding the rotor are neodymium magnets, and as that blade set spins around the rotor, the copper windings on the rotor, the output of the stator is wild AC, 3-phase wild AC, which then gets rectified right here in the circuit card and rectifier block to regulated 12, 24, or 48 volt DC. This is the wire harness that includes the potentiometer screw as well as the LED. I'll talk a little bit more about that in a minute. Here's an O-ring, which means the turbine is sealed. It's not fully sealed from the environment, but it does a good job of keeping most everything out. This is your yaw bearing, and this is your yaw assembly with your brushes. This allows the turbine to spin or yaw 360 degrees without the wires getting crossed. And that is what the turbine, the major components of the turbine. So our turbines look like this. They either are a land turbine. This is the land units. This is a gray cast aluminum housing. And this is the marine version. These are the white aircraft quality paint, corrosion resistant paint housing. So all of our marine turbines, that's kind of the primary difference. There's a couple of internal components that are stainless steel and so on, but all of our marine versions, the biggest difference is this white aircraft quality paint. So this is the, excuse me, 6, this should say 6, I apologize. The 6 turbine types and the different blade sets we have. And I just want to quickly go through the different turbines and what they're used for. So Air 30 is our kind of industrial oil and gas telecom turbine. It comes in all 3 voltages. It's land, so it's gray. It's designed for a high wind speed environment, like the top of a mountain where a telecom tower is, oil and gas sites, offshore sites, excuse me, not offshore because it's a land turbine. But it is loud because it has a louder blade set, which I'll show in a minute. This is the Air Max. It's basically this Air 30, and we apply the very quiet carbon fiber blades I showed you earlier, those multicolored blades. And we use it for all kinds of purposes. Anywhere where you have a high wind speed environment, could be residential, it could be educational, anywhere where you have a high wind speed environment, but you want the turbine to be quiet. When I say quiet, these carbon fiber blades are less than 40 decibels, whereas these blades for the Air 30 are over 100 decibels. So the Air 30 is really just industrial. The AirX Marine is the marine version of the Air 30. It's industrial, offshore, oil and gas, telecom, buoy applications. high wind speed, but high sound. Again, over 100 decibels. The Air 40 is kind of our basic land version turbine. It's our least expensive turbine. It's residential education. It is fairly quiet. It's about 65 decibels, designed for kind of a low to moderate wind speed environment. It has wider blades, but it's not a turbine you want to leave and not hit the stop switch when you have very high wind speed events. You want to be around if you're going to buy the Air 40. It needs to be at your cabin, somewhere where you're going to be around, because if there is a high wind speed event, you would want to shut it down. It's designed to really work well in applications where you have kind of a low to moderate wind speed environment. The Breeze is the same thing as the 40, but marinized. It's the marine version. Again, low to moderate wind speed environments, low sound, 65 decibels, often used on cruising sailboats and so on. The Air Silent X is the upgraded version of our marine. It's for cruising sailboats who want a very low, want a very robust turbine that's also very quiet. It is more expensive than the Breeze, but it's because of these carbon fiber blades. So it uses those same carbon fiber blades we were talking about before. So here's the blade set. You can see here's the 40 Breeze blade set. See how it's wider? It's got about a 30% more surface area than the Air 30 blade set. So really designed for kind of a low to moderate wind speed environment, typically low towers, short tower heights, and so on. This blade set tends to be very loud, over 100 decibels. This is below 65 decibels. So there are advantages of both. I just went through that. Happy to explain that to you in more detail if you need that explanation. So we're talking about hybrid systems here. All of 99% of the systems we sell are hybrid systems. And we're talking about combining PV and wind, going to the battery bank. That's the common thread between the PV and the wind to power your loads, right? That's what our systems do. And here is a standard hybrid solution line diagram right here. So right, you got your PV array, you got your charge controller going through your ammeter, you got your J box, your battery disconnect breaker for your solar side, and then that goes into your battery bank, right? The wind works really nicely with solar, but it's autonomous. Is not connected through the solar charge controller. The only thing common to the PV and the wind is the battery bank. Both of these systems are always looking at voltage of the battery bank to do what they do. Like the PV is going to switch to absorb, float, you know, all the different finesse charging modes that the solar charge controller offers. Our turbine is what is called a bulk charger. It is either on or off. For instance, in a 12 volt system, when our turbine reaches 14.1 volts, it's going to shut off. Then when it goes 5% below that, it'll automatically turn back on. It's a bulk charger. That's what our turbine does. It's designed to get it up to a certain level of voltage in your system, and then the PV solar charge controller takes it that last 2 or 3 or 4% with the finesse charging. And so our turbine, very similar, right? You got 3 wires, the black, the red, and the green. The green goes to your earth ground. The black and red go through a stop switch, an ammeter, breaker definitely, sometimes a battery disconnect, and then directly to your battery bank. Both systems are looking at battery voltage. That's what they're doing. So on the side of the turbine, I'll show you in just a minute, is a potentiometer screw. And so here's our factory set points for the 3 different turbines we sell. It is adjustable within this range. So in some situations, you might want to adjust, depending on your battery type, that pot screw. And this is all in the manual, but it's a fairly simple adjustment using just the pot screw on the side of the turbine. Here's the pot screw I was talking about. Apologize for these pictures, but this is just a mechanical pot, right? You stick a flathead screwdriver in there, turn it 1/8 of a turn to the right to increase the pot, and turn it 1/8 degree to the left to decrease the pot, and so on. All of that information is in the manual. Here's the LED. A lot of people, even still, I know, will receive a turbine and never even know that the LED is there, which is amazing. It tells me they don't read manuals, but you really want to know that this LED is right here. So it's a red LED, and the LED functionality is this. Once you connect the turbine to the battery bank upon first installation of the turbine, when your tower is down, you want to look for the 2 initial slow blinks. If you don't get those, then you know there's some kind of a wiring issue or potentially something going on with the turbine, but 90% of the time it's a wire issue. So you want to look for those 2 initial slow blinks before you raise up your tower. Then once your wind is blowing, you're going to get a solid LED. That means your turbine is pushing amps, current in amps, DC amps, and it's usually above about 450 RPMs and above about 7 or 8 miles per hour of wind. And this LED will illuminate, and that says it's pushing amps. That could mean it's pushing 1/8 of an amp, or it could be pushing, 12, 15 amps. But LED solid means amps are current is going down to your battery bank. If it starts blinking slowly, this LED right here, that means you're in regulation. That means the turbine has seen the appropriate battery voltage, again, 14.1 for a 12-volt turbine, and it says shut down. Apply the electromagnetic brake, which is how the turbine brakes. That's a short to the windings in the stator electronically, and it shorts the windings in the stator. It'll slow down the rotation of the blade set. It won't stop the blade set if there's high winds. It'll slow it down below that 450 RPMs, and it'll not push amps to the battery bank so it doesn't overcharge the battery bank. Then once your battery, when a load comes on or if solar decreases, then as soon as that battery voltage drops below 14.1, it'll automatically start back up again. Remember, it's a bulk charger, on or off. Also remember the turbine is voltage specific. Voltage specific, meaning you have to purchase the correct turbine for the correct voltage of your battery bank. If you have a 12-volt battery bank, you need a 12-volt turbine. And it's not easy to change out the turbine. It's not field changeable. You have to change the stator and the circuit inside the turbine. So make sure you purchase the correct turbine for the correct voltage of your battery bank. The last thing on this LED is fast blink. And fast blink means you're in overspeed protection. So that when the wind speeds are above about 35 miles per hour wind, it depends on a lot of things, gusting and so on, then the turbine will start blinking rapidly. That means it will go into overspeed. It'll apply the brake for a period of time. It could be anywhere from 30 seconds to 6 minutes, depending on the control algorithm and where it's at within that control algorithm. And then it'll automatically release, check the wind, and keep doing that until your wind speed has died down. That's called overspeed protection. One little thing we kind of recommend is a wind control panel. It's nice because it has a breaker sized to your voltage in your system and the turbine, a stop switch, and this analog ammeter. This is our lower end unit. I really recommend this unit. It's not that much more, but it's a digital meter. It combines your stop switch and your breaker, but it has a digital readout of voltage, current in amps, DC amps, power, instantaneous power in watts, and then energy over time in watt hours. This is really nice to have, especially if you want to kind of keep track. This little button right here allows you to reset this watt hours and to see kind of how much you've been producing. So this is a nice little add-on. It's not a must-have. Only thing you really need between your turbine and your battery bank is a breaker. Stop switch is a really good idea. But if you want a whole kit and caboodle and have a nice little setup, this is really nice to have. It has all those components, and it's in an enclosure, an ABS plastic enclosure. It's an indoor rated enclosure, not outdoor. So a little bit about maintenance. I get this question a lot. Maintenance on our turbines is really minimal, but you want to get up to it about, in after the first installation, first 1 to 3 months, you want to check blade bolts, yaw bolts. You want to check the blade set. You want to check everything to see if it's spinning and working correctly. Do a power cycle on the turbine, meaning hit that stop switch, let it go to stop for about a minute to drain the capacitors, and then restart it after a minute. That's another nice thing about having a stop switch in the system, is you can do a power cycle on the turbine. Confirm you get those 2 LEDs up to your turbine. Do that power cycle. That's really nice thing to do every few months. And make sure you check your rotor bolts as well, and so on. That's what you should do in the first couple months of the install, and then about every 12 to 18 months thereafter. So you really want to be able to get up to your turbine. So any tower you choose, keep in mind that you want to be able to get up to your turbine every year or year and a half. Okay, so we do have parts and service through through Primus and through Denver. You want to learn more about that. If you want to learn more about the loyalty program, if you have an air turbine, you want to get it upgraded, you can find all about that under our Primus Wind Power support tab. Let's talk a little about tower height. So as you go up in tower height, as you can see from here, going simply from 10 meters, 33 feet to 45 feet, you're going to get about a 20% increase, assuming good laminar flow of wind, no obstructions, no turbulence. You're going to get a good 20% difference in power output, but going from 33 to 45 feet may also cost you $1,000 or $2,000 in the type of tower you buy. So especially with a micro wind turbine, tower height is not as critical because the turbine is, $1,000 or less. Average price around $1,000 for the turbine retail. So you don't want to spend, $2,000 on your tower, but you really want to try to get up as high as you can, because that's going to give you the best laminar flow and minimize surface roughness in terms of your power output. Really, what's more important is siting the wind turbine properly. So right here, if this is the prevailing wind direction and you have a building or a tree right here, this is the best place to put a turbine, on the prevailing wind side of any object that's going to cause turbulence. Look at these lines right here. These are called laminar flow lines. These are called turbulent flow lines. You want to avoid turbulent flow lines. Turbulence is the killer of wind power. We have a saying in wind, this goes for any wind turbine, small wind turbine, that 2250. So the turbine should be 20 feet above and 250 feet away from any object that's going to cause turbulence to get the maximum power output out of your turbine. 2250, a good rule to remember. It is not always feasible in micro wind to get that. Probably 50% of our turbines installed, they don't deploy the 2250 rule, but it is good. It is a good rule of thumb if you want to get maximum output out of your turbine. Over here in this picture, you can see anything on the water or close to the water. Great laminar flow because of no surface roughness on the water. So you're going to get good output out of your turbine. On a hill, as the wind flows up the hill, it begins to compress. The laminar flow lines begin to compress. That causes increase in velocity. That's why typically on hills and mountains you have higher wind speeds. And then you're going to get good flow, assuming no surface roughness. But if you're talking about a cliff, mesa, plateau, or building, you're going to get these turbulent effect out of your turbine. So any building mount turbine, just keep in mind, and we do sell a building mount kit, but the building mount turbines are going to reduce your power output. It's really important for you to know that. It could be 5% depending on the design of the building. It could be 50% depending on the design of the building, but that is something important to know. What we're talking about here is hybrid systems. Like I said before, all of our systems pretty much are hybrid. I love solar. I have it on my house in Flagstaff, Arizona, but it does have a few drawbacks. And solar has low output during the winter months, kind of common sense. Diminished output during bad weather, common sense, and obviously no output at night. So where wind power comes in handy is the average wind speed is higher during the winter months. We know that across the United States and North America. Air density is higher during the winter months. And why does air density matter? Because it's part of the wind power equation. If I can just geek out with you here just for a minute and just tell you that the wind power equation is three factors, three components: air density, wind velocity, which is cubed, and swept area. Our swept area, if you remember, is 1.2 meter rotor diameter. That swept area is about a meter. And so these three factors are how you calculate wind power, the amount of power you're going to get out of that wind turbine. And air density is one of those factors. And we know air density increases during the winter months. right? We also know wind is on average is stronger during bad weather. It's kind of an obvious thing. When there's weather, there's wind. And wind does frequently blow during those long winter nights. If you've ever been in Cheyenne, Wyoming in February, you can certainly attest to that. So those are the things that we think of. And so what we say is hybrid systems are complementary. In the summer, you're not really going to need or get much out of that wind turbine. It's, you know, maybe during the bad weather periods, it's going to blow maybe a little bit at night. But really when you need it is the winter months, when your system is designed for that 50% depth of discharge on your solar. That's when the wind turbine kicks in. The complementary nature of wind and solar is kind of, it's all right here in this slide. We also know that there's a lot of good places across the United States that have great wind. This is a wind resource map for the winter months. The darker the blue color, the better the wind speed, right? The higher the wind speed. And you can see here, the middle of our nation is why a lot of the big wind turbines, the industrial scale wind turbines, are located in Texas and Oklahoma and so on, Kansas, because we know this is where a lot of the really good winds occur. You can also see along the coastline, that's pretty obvious, you have good wind. In Texas, a lot of great wind. These little islands of wind are mountaintops, you know, the Cascades, the Rockies, and so on, all the way up the coast. So we know we have lots of good wind. So how do you really determine what your wind speeds are? Well, we'll help you with that because we have a free wind resource you can send to us or Renvu. And you just send us your data coordinates, your decimal data coordinates if you have them, GPS, your address of your off-grid site, and we will send you a report that gives you not only your monthly average wind speed as low as 10 meters of tower height, it'll also give you a wind resource assessment of your prevailing wind direction. Again, all we need is your address, decimal data coordinates, GPS, and we can determine if you are a good candidate for a wind turbine. What we're looking for is 4 meters per second or greater of winter wind speed. Let me repeat that. That's 4 meters per second. That's about 10.5 miles per hour of winter wind speed. We also want you to be open to the prevailing wind direction, not surrounded by trees to cause turbulence, and consider all those factors. If you think you have a good site for a wind turbine, then you might be a really good candidate for a hybrid system. If you're below this 4 meters per second or greater, then you got to consider, okay, do I still want to add a wind turbine? Are there other reasons why I might want to add a wind turbine? So this is my house in Flagstaff right here. I just want to show you what these wind resources looks like. You're going to get a monthly distribution, January through December. And you can see here, I'm kind of on the edge, right? And you really want to look at the winter months, January, February, November, and December. I'm pretty darn close to 4 meters those 4 months. And right here, you can also see that the tower height, right here, this is the number that tells you the tower height on your report. That's 45 feet, 14 meters, right? Here's the same resource assessment, but it gives you the wind rose. This is actually really more commonly called a power rose because it tells you where the predominant power of the wind is coming from. The nice thing about this report is then this will help you site your turbine. This little dot is where I sited the turbine. So off to the southwest, I actually have pretty small trees right here. So I have some pretty decent, I'm fairly open to the southwest. So that's why you want to have the wind rose as well to tell you where the power in the wind is coming from. You can see I get wind from the northeast and the east, but the predominant wind direction is out of the southwest. Here's another site. Obviously, this is a pretty darn good site off the water. Here's the turbine. You can see a much higher wind speed here, right? Almost 6 meters per second for the November, December, January, and February months. You can see the tower height is 14 meters or 45 feet, right? So, and then here is the power rose, the wind rose this is, what I did was I changed the tower height here. Let me back up. So look, if you see right here, we're almost at, just below 6 for winter months, right? With a 5.21 meters per second average. We don't look at the average. We don't care about summer months. What you care about is winter months, right? But if you, and here it is, 45 feet tower height. If we switch it to 10 meters or 33 feet tower height, you can see how that number goes down. So tower height matters, right? You want to be up as high as you can. That's reasonable and cost effective. So the higher you can get up that turbine, the better. But again, sighting the turbine is really the most critical. Here is the sighting report, the wind rows for this particular site. You can see the predominant wind direction is out of the northwest, but you have a lot of power here almost out of the west and all the way over to the south, which at this site, you're open to all of that area. So this is obviously would be a very good site for wind. We know that the solar day is different from June to December. That's why Renvu would size your system for December 21st, the shortest day of the year, with a 50% depth of discharge on your battery bank. So that's why putting a wind turbine into the mix really changes that whole paradigm for how you size an off-grid system. Because if you have a turbine in there in December, you're going to get that current in amps into your battery bank when you need it the most, when you have the most wind. That's why that secondary charging source of a wind turbine, making it a hybrid system, really makes a lot of sense. You're also going to be getting power into your battery bank in the nighttime when there's no amps flowing in the battery bank in a normal solar system, non-hybrid system. And that's when you're often using a lot of power from lights and so on. You're depleting that battery bank. There's a lot of studies that show that the putting amps current in your battery bank throughout the day, 24 hours a day, or as often as possible, keeps the sulfation down. There's a lot of benefits to, especially with a lead acid battery, a carbon infused battery, not so much with lithium. Lithium, is not as critical, but especially a lead acid battery bank, which is still 95% of our systems that we sell, and Renvu sells probably, are lead acid battery banks. But there's a lot of advantages to having that current flow into your battery bank as often as you can, not just during the 4, 5, 6, 7 hours of sunlight that you have where you have a solar amps going in. So really, it's all about keeping those batteries happy. This is a Trojan battery brochure right here, and here's again what you're typically max depth of discharge, 50%, right? But if you can get that turbine up into the 30-40% range for max discharge depth, look how steep this curve rises. And this is pretty typical, a pretty typical battery performance curve for lead acid batteries. Obviously, it's very different with lithium batteries, but you can see how much steeper this curve is. And this vertical axis here is number of cycles. That's essentially your battery life, right? If you can increase the number of cycles on your battery, then you can get an extra 6 months, 12 months, 2 years out of that battery. Increase that battery life before you have to change it out. That saves a lot of money because the batteries are obviously the most expensive, typically part of the system, and they are typically the most perishable. They last, what? You're going to get 4 years out of a sealed lead acid battery. You might get 7 or 8 out of a flooded lead acid battery. So if you can extend that battery life, it's going to save you not only time, money, aggravation, frustration, and so on. And that's kind of what a hybrid system does. It helps to extend that battery life and help you to save money, essentially. So with the last few minutes here, before we take questions, I'm going to show you a bunch of pictures of different installations, and we'll be able to answer your questions at the end as well. So here is a 45-foot guide tower. Remember, all of our turbines will accept this 1.5-inch Schedule 40, Schedule 80 pipe into the yaw. That's this part, the part that spins, right? That turns 360 degrees, allows the turbine to spin 360 degrees. 45-foot guide tower has 8 guy wires. And it is 45 foot tall, obviously, but it's a very inexpensive way to get your turbine up high if you have the room for the guy wires. This is a small off-grid cabin, typical system, 400 amp hour battery bank, relatively small system with a turbine helping to supplement the solar. Here's obviously a very remote location right here on a very short tower. This is our 27-foot tower kit that they used a short pipe. But you can see in this particular situation, they don't need a lot of tower height because they have very little surface roughness, very little obstructions to prevent that flow of wind or create turbulence. You have this volleyball net here that might create a little bit of turbulence, and that's about it, right? So it really depends on the site. Always best to get up as high as you can to get that nice even laminar flow lines of wind, but a lot of places you can't do that, nor is it really that critical, right? So here is cruising sailboat. We sell, a big portion of our market is a cruising sailboats. We make this mast and stay kit that is a mast and stays that come down to support the mast. And this is an air breeze turbine on top of this mast and stay kit. But you can see, this is the way the wind will be flowing, right? You're going to get turbulence off all of this rigging in front of the turbine. With this mast being up so high, it really reduces. But these little wires, this mast, all this stuff causes turbulence. So even in a sailboat, you're not going to get, even if it's at sea level, you're not going to get the full power potential because turbulence is the killer of wind power. But it's going to do a nice job because there's not a lot of room for solar on these sailboats, right? This is a parking lot installation, right? Using solar and wind, our turbine, solar and wind. So we see our turbine used in all kinds of applications. This is just a simple, 4-inch square tubing parking lot light where they have then they transition to the 1.5-inch Schedule 40 pipe. Not a huge fan of this installation because the solar panel is so close to the wind turbine. You can see there's quite a bit of turbulence that would be generated off of this solar panel. These are oil and gas installations. You can see very short towers here. This is, North Dakota, Wyoming, West Texas, where you have very high wind speeds, where they don't really need tall towers and they're just supplementing the solar. But very good applications for solar in this off-grid setting. These are little pick-and-place portable systems where you have 500 watts of solar. You have, about 400 amp hours of battery down here. This is a Roan lattice, self-supporting lattice tower with this 1.5 Schedule 40 pipe, stub pipe that flows up through the Roan tower. And you can extend it. Roan makes a nice little inexpensive lattice tower. We don't sell them, but that's ROHN, Roan, for a fairly inexpensive system to install a turbine, our turbines. But this is a nice little pick and place system using our Air 40 turbine. Again, relatively short tower, about 17 feet tall or so. This is a buoy application at a mine facility. Here is some portable applications on trailers. These, obviously the turbines tilt down when these trailers are being moved, but we see our turbine used in all kinds of interesting applications. Here is if you haven't figured it out, the bottom of the world, because the vertical solar panels, right? This is Antarctica. The one I wanted to point out this picture is if you're going to be doing multiple turbine applications with our turbine or anybody else's, you want to make sure you minimize the downwind shadowing effect of the upwind turbine. What do I mean by that? Well, here is the upwind turbine right here. This one is, you can see because the blade set is facing upwind. This is the downwind turbine. So you see how it's at a different elevation than the upwind turbine. And so if you can get them offset like that, that means you won't have that downwind shadowing effect, which would lower the output of the downwind turbine. And so that's why these turbines are at different heights, elevations, to minimize that downwind shadowing effect when you're installing multiple turbines at a single installation. Here's another Here's another application of a buoy hybrid system. Again, two different elevations here for the turbines to minimize any downwind shadowing effect. Very good winds off of the coast here, obviously, so they don't need to go up very high. These are Nlx marine turbines for industrial applications. This is a telecom application coupled with solar and wind. I'd like to see this turbine not so close to the solar panels, but again, it's really high up there, so they're going to have some really darn good winds, but it will be turbulent. What you'll see in a turbulent wind application is this turbine spinning or yawing a lot. That is an indication of a very high turbulent site, which is generally not something that's good long term for the turbine for it to be yawing a lot, but it'll survive. It'll do okay. You will have to pay attention to the brushes and the slip rings due to the extreme yawing of the turbine. So something to keep in mind. This is a railroad application for positive train control. They used to use a lot of propane generators. Now they're using solar and wind for these types of applications. This is obviously on a little RV there, and a little palapa here in the Sea of Cortez. We see our turbines being used in all kinds of applications. Very incredible what our customers will do and how they'll install our turbines. This is the last picture. It is a telecom site in Alaska. You can see pretty darn short tower here, only about 12 feet tall or so, but again, very little surface roughness. And basically this turbine, you can see the wire coming down here going right into the battery, small panel, just trying to supplement the output of that frozen up solar panel. So lots of different applications for our turbine. I really appreciate your guys' time and love to answer any questions that you might have. So back to you, Daniel.
Thanks, Ken. Yeah, before we get into questions, I do want to talk about an exciting product that would actually pair very well with a Primus Wind Power turbine, and that is the Bleakier carport that Renvu is working with. The Bleakier carport is made in the USA. It does have a 25-year warranty and is basically designed around a very easy installation. This is a 2-car carport that can support 24 60-cell modules or 18 72-cell modules, and both configurations do utilize Iron Ridge XR100 rails. It is a sealed surface using T-gaskets in between the modules for a more waterproofed carport. Bleakier did design this carport to be easy to install, and it only requires a pier depth of 2 feet, and it can withstand a 35 pounds per square foot snow load and a 130 mile-an-hour wind load. Now, that 130 mile-an-hour wind load is something that would be needed in these places where we are going to be installing those wind turbines. So this is a carport that could withstand those high wind areas. We do have options that do that can support winds up to 170 miles an hour and snow loads up to 65 pounds per square foot. Those are available as well. The carport does stand 9 feet tall with a 5-degree tilt angle and a pier-to-pier length of 18 feet on all sides. It doesn't matter which direction the cars enter from, so it's kind of nice if your solar resource is facing, to the left of your driveway or the right of your driveway. You can orient that carport whichever direction you need to. There is a decorative mesh option that is included, or sorry, not included, but it can be purchased as an add-on to hide everything from underneath that carport as well. A few things that we are offering right now with the Bleakier carport is a Enphase IQ7 system with 24 phonosolar 60-cell modules, and also a residential solar and carport kit with a battery. including a Solar 12K, which you can also pair that pretty well with a Primus Wind Power system, a Fortress Power battery to store all that power that you're generating, and those same 24 60 cell 310 watt phonosolar modules. Bleakier does have a authorized installation program, which does require you to submit an application form, install 3 carports, and then from there you will be able to unlock quite a few benefits. Once you do install 5 of those carports per month, we will give you $1,000 per carport that is installed, and that is tabulated quarterly. So if you only install a few in the first month or something like that, you can make up for that later down the road. We do have the solar kit guide, which allows us to design our system. If this is something you have not done before, you can actually include wind power into these designs as well. So if you want to explore a hybrid system and combining your solar and Primus wind power into one system, as Ken was saying earlier, this would be a great little tool to help you get started there. You can go through, change where you're located, what type of installation for the solar that you're working with. Is this a tilted roof, a flat roof? What type of inverters are we going to be using for the solar? Do we need rapid shutdown? So on and so forth. And then we can go into calculating that battery bank size. From there, you can enter in different applications and appliances, or if you just know what your critical usage is, you can enter that as well. You can choose from your lead acid batteries, your lithium ion batteries, and scale those battery banks up and down based on your energy needs. And finally, if you'd like to add in a car charger, you can do that as well, or a smart home consumption energy monitoring system. You can also choose to have a full permitting package, so that way you can encompass everything together and get your energy system passed through your AHJ and utility company. And that's the great tool that Renvu does have, and it will assist you in all of your Bleakier and Primus wind power system sizing. Before we do get into that question and answers, we will be having a new another webinar on the 21st of April. This will be at 9 a.m. Pacific time with Spain's ice engineer about their floating solar systems. So if you want to tune in for that, we will be sending out a email for that as well. We do have a special offer with the Primus wind turbines for the AIR 30 and 40 wind turbines. If you purchase one of those through Renvu, you will receive a $100 gift card. So please reach out to us at info@renvu.com for more information on that. And let's go ahead and jump into some questions. All right, Ken. Do you see any questions that you want to go, or do you want me to ask you some questions here?
I just see this from Jack about the wind turbine in Texas, high failure rate. Yeah, Jack, our turbines are sealed. They're designed for weather. Like you saw that picture of the one in Antarctica. We have them all over the world, tropical, cold locations. And so that is not a situation that we have problems with. Sometimes we'll see on sailboats, if the sailboat gets turned over or heels in a storm and it gets dunked, yeah, we'll have some water infiltration and so on, but yeah, not a non-issue. Drew asked, is there a dump load? No, our turbines do not dump. They are a bulk charger. They turn on and off based on the battery voltage, as we discussed. If they're disconnected during an electrical storm, if you hit the stop switch, it'll apply the brake, but that's why you have to have it grounded, obviously. And if you're in a high electrical activity, I recommend the Midnight Solar. Midnight makes a really nice arrestor, lightning arrestor, and I would recommend that to add to your system. But that's just for transient strikes, Drew. If it's a direct strike, Drew, all bets are off. Any direct strike to the turbine or components of a system, you can't. No arrestor is going to be okay with a direct strike. Only transient strikes, which are the majority of strikes, by the way. Ramon asked about a grid connected systems. We don't sell grid connected systems. We're off grid only. And I can't recommend any grid connected wind turbines out there, unfortunately. Our turbine, I don't recommend you grid connect either, because you have to go through a grid capable solar charge controller, which gets pretty darn expensive. Let's see. Ramon asked about when servicing upkeep, do you have to lower the tower? It depends on what tower. If you can get to it via a ladder or some other way, sure, you can do it up tower. But a lot of times with a lot of the towers that we sell, typically the customer will lower the tower, and that's how you get to take a look at it. It's best if you don't have to, right? Is it possible to install a hybrid system with no batteries? That would be a grid connected system, I guess. And no, our turbine has to see battery voltage for it to work. And without battery voltage, the circuit will not activate. So it absolutely has to see battery voltage. Daniel, I think there's some questions for you on there about the carport and stuff.
Yeah, I can address those. Can you get a higher tilt angle on the bleakier carport? Currently, right now, we do just have the 5-degree tilt angle currently, but this is something that we are able to make custom installations for. So if you do want to reach out to us and let us know what tilt angle you are interested in, this is something we will be able to work with you on. Let's see. Will the carport solar kit support electric car charging? Yes, this is something that you can pair with an Nlx car charger. We actually have a bundle that does include the Nlx 48-volt car charging kit. So Jack, that is something that the solar kit carport does include. Let's see here. Let's see about the carport in Miami. The building department does require a 175-mile-an-hour wind exposure load. Now, this is something that can be accommodated for with larger footings and insulation. The 170-mile-an-hour wind load is for an exposure C rating system. So it really depends on the job site's exposure itself. This is something that can be accommodated for. So if you want to reach out to us at info@renvu.com and let us know where you are installing specifically in Miami, we will be able to work with you. What is the cost for the solar kit guide? That is a completely free tool that is on renvu.com. It is on the home opening page. So if you just go to www.renvu.com, you can go ahead and use that solar kit guide and even produce yourself a quote in a few minutes.
I'll jump in, Daniel, for a couple.
Go ahead.
This question from Jimmy about assuming a hybrid system is ideal, can wind turbines and existing solar systems be installed separately on a residential home? Why or why not? It really all depends on your jurisdiction. For our turbine, all you have to have is a battery system of about 400 amp hours or larger. That's at 12 volts. And yeah, you can install it there, but it's really your jurisdiction. Typically, we found for residential settings, especially high density residential settings, the jurisdictions are not very hip for that. That's why 90% of our systems are really off-grid remote cabins and so on, places where there's really no jurisdictional overreach. But you could certainly install the solar separately from the wind. All the wind needs is a battery bank and wire to get to the wind turbine. And then there's a question here about a 12 by 30 camp house with a fridge and a 913K mini split. Stove and water will be gas. What will a dual system cost approximately? You really need to go through Renvu to get the cost. I can tell you basically a turbine, our basic Air 40 turbine, around a little less than $1,000 retail. And then with the wire components, if you do a guide tower kit, you're another $500, $600, $700 for those items. If you decide to add a wind control panel, you're another $299 for a digital wind control panel approximately. So, it's then you have to add your batteries and your solar and all that. So you really need to have that sized and priced out by Renvu. But that's kind of the approximate cost for what the wind turbine alone would be. Go ahead, Daniel.
Let's see here. Is it possible to install a hybrid system with no batteries? Typically, from what I'm getting from Ken, is that you cannot do that with a wind and solar system without batteries. If you really wanted to, you could include. I don't think you could include wind. Would that be correct, Ken?
No, you can't. Yeah, no, it's got to have batteries. The turbine is 12, 24, or 48 volt. It's voltage specific, and it has to see batteries to operate. It will not work without batteries. So even if you wanted to do a grid tie system, you'd have to have a battery in between. I don't recommend it, but there has to see batteries. So Daniel asks about a Southwest Wind Power Whisper unit. Top of pole mount, and this is industry standard, and would the Primus generator plug and play mount on my pole? If it's a Whisper 100 or 200, Daniel, it is a 2.5-inch pipe, and no, it would not. You'd have to have to build a flange of some type with a reducer, coupler reducer to go down to 1.5 pipe, and then you could then insert the 1.5 into that flange and be able to reduce it down, have about 3 feet of pole between the 2.5 and the 1.5 pipe, and then you run the wires straight down the battery bank. Would it be plug and play? No, because the Whispers were a down tower controller, AC, wild AC unit, and remember ours is DC, so likely the wire size would probably be different. So it would not be plug and play, but you could change out that Whisper. Remember, the turbine, our turbine is much smaller, 46 inches, about almost 4 feet, whereas the Whispers were about 7 feet rotor diameter. So very different turbines. And yes, chicks do dig wind turbines. There was a question about that. At least I think so, anyway.
Well, great. Patricia, if you do want to email us at info@renvu.com, we can definitely help you with pricing that dual system for you a little bit more accurately and give you an actual quote on that in East Texas. And let's see, I think that's going to be it, unless you see anything else you want to address here. It looks like those are all the questions there. Thanks everyone so much for tuning in today. Thank you, Ken, for giving us all that information on Primus. It's very informative. I think those wind turbine systems are really cool, and I think they need to be installed more often, in my opinion. Just
thank you, and thank you for being part of this, Daniel. I appreciate everybody's good questions and attention.
Yeah, and just so everyone does know, this was recorded and this will be emailed out to everyone in case you were unable to attend or want to go back and look at those slides and whatnot. Thank you guys so much for attending, and if you want to join us on April 21st, we will be having that additional webinar with Spain's Ice and Jenner about their floating solar systems. So if that's something that interests you, go ahead and tune in, and we'll talk to you then. Thanks so much. See you guys.
Thank you. Bye.